At the professional level, they only last 9 games. In a single match at Wimbledon, over 50,000 are used. To the casual player, it's just a fuzzy yellow ball. But to an industrial engineer, a tennis ball is a high-precision pressure vessel designed to survive a 140-mile-per-hour impact while deforming to nearly half its size and snapping back in milliseconds. If the pressure is off by just 1 pound per square inch, the ball is dead. If the fuzz is a millimeter too long, the aerodynamics are ruined. Today, on Process Sector, we are stepping inside the massive production lines of Penn, Wilson, and Dunlop to see how raw rubber and neon felt are engineered into the most consistent bounce on the planet. The engineering goal: why the fuzz? Before we see the machines, we have to answer the biggest question: why are they fuzzy? It isn't just for grip. In the process sector of aerodynamics, that fuzz, technically called nap, creates a layer of turbulent air around the ball. This creates drag, which slows the ball down so it's actually playable and allows the Magnus effect to take hold, giving players the ability to hit high-velocity topspin. Without that specific factory-engineered felt, a tennis ball would fly like a ping-pong ball on steroids. The core, molding the pressure vessel. The rubber alchemy. The journey begins with raw natural rubber shipped from Southeast Asia. In the factory, this rubber is fed into a Banbury mixer. This isn't just a blender. It's a high-pressure cauldron where the rubber is mixed with sulfur, carbon black, and several secret chemicals that determine the ball's final elasticity. The mixture is rolled out into thick sheets and fed into a pelletizer. This machine snips the rubber into small marshmallow-sized cylinders called slugs. Every slug is weighed by an automated scale to within 0.1 grams. If the slug is too heavy, the ball will be too hard. If it's too light, it won't meet the ITF, International Tennis Federation, weight standards. Forming the half shells. The slugs are placed into massive hydraulic presses. Under intense heat and pressure, the rubber is forced into half-shell molds. In about 90 seconds, the press opens to reveal hundreds of perfect rubber bowls. A robotic arm sweeps them onto a trimming line where high-speed circular blades remove the flash, the excess rubber around the edges. These half-shells are now ready for the most critical step in the factory: pressurization. The heart of the ball. Pressurization and bonding. The chemical injection. How do you get air inside a sealed rubber ball? There are 2 methods used in the factory. 1. The compressed air method. The half shells are placed in a chamber that is pressurized to about 18 psi. While under pressure, the 2 halves are glued together. 2. The chemical pellet method. This is the more common industrial magic trick. A small tablet of sodium nitrite and ammonium chloride is dropped into the half shell. As the 2 halves are fused together in a high-heat press, the heat triggers a chemical reaction inside the sealed ball. The tablet vaporizes, turning into nitrogen gas. This gas expands, creating the internal pressure that gives a tennis ball its pop, the edge, grinding, and adhesive dip. The sealed cores, now looking like smooth black handball balls, are sent into a giant tumbling drum filled with abrasive stones. This scuffs the surface of the rubber, creating microscopic grooves. This is vital for the process sector because, without a rough surface, the glue won't hold the felt during a 140 miles per hour serve. The scuffed cores are then dipped into a vat of white, liquid latex adhesive. They emerge looking like ghost balls and move on to a drying rack where the glue becomes incredibly tacky. The fuzz, the woven aerodynamics. Cutting the dog bones. While the cores are drying, another part of the factory is preparing the iconic yellow felt. This isn't cheap craft store felt. It's a high-strength blend of wool and nylon. The felt is actually woven and then milled to make it fuzzy. A massive clicker press uses steel dies to punch out thousands of pieces of felt in a very specific shape. In the industry, these are called dog bones or dumbbells. Because of their geometry, Two of these pieces can wrap around a sphere with zero gaps and no overlapping, the wrapping and vulcanizing. This is the most satisfying part of the assembly line. In a fully automated process, two felt dog bones are picked up by vacuum arms. They are coated in the same white adhesive on their edges. A precision machine wraps the felt around the tacky rubber core. It looks like a puzzle coming together. But at this stage, the felt could easily be peeled off. The balls are moved into a final vulcanizing mold. Under heat, the adhesive on the edges of the felt and the adhesive on the rubber core fuse at a molecular level. This creates that iconic seam you see on every tennis ball. The final steam and packaging. The steam bath and grading. When the balls come out of the vulcanizer, the felt is flat and matted down. To give them their fuzz, they enter the steam tunnel. The hot moisture causes the wool fibers to expand and fluff up. The balls then undergo the ITF compression test. A robotic piston squeezes the ball. It must deform by exactly 0.22 to 0.29 inches under a load of 18 pounds. If it's too soft or too stiff, it's rejected and sold as practice balls or dog toys. The pressure-sealed can. Because rubber is naturally porous, the nitrogen gas inside the ball will eventually leak out. To stop this death before the ball even reaches the store, the factory must use equalized pressure packaging. The balls are dropped into plastic cans, and the machine overpressurizes the air inside the can to match the 18 psi inside the ball. A metal ring pulls a foil seal tight. As long as that can is sealed, the pressure inside and outside the ball is equal, so the gas stays trapped. This is why you hear that satisfying psh when you open a new can. That's the sound of factory-fresh engineering escaping. The process sector final word. The next time you're watching a match at the US Open or hitting at your local park, take a second to look at that yellow ball. It is a masterpiece of material science. A chemical reactor, a pressure vessel, and an aerodynamic wonder, all wrapped in a wool blanket. From raw rubber slugs to the pressurized can, the tennis ball factory is a testament to how we can mass-produce perfection. So, do you prefer the extra-duty felt for hard courts or the regular duty for clay? And did you ever realize that new ball smell was actually the scent of vulcanized rubber and fresh nitrogen? Let us know in the comments. If you love this deep dive into the process sector, hit that like button and subscribe. We're going from the court to the construction site in our next video. Wait until you see how they manufacture massive excavators.